the moment arm and the perpendicular component of the force for this 45 Newton downward force. This shows that that's drawn halfway up the post, so we've marked this as L over 2, and we know that's going to be 2 meters for this side right here. Okay, let's draw the R perpendicular first. So our pivot is up here at the top. What we know is that our R perpendicular, our moment arm, connects the pivot to the line of action. To draw our line of action, we extend this force, we make it as long as we can. Then we want to draw a line that's perpendicular to this one and goes over as far as the pivot. So we take our ruler, put it perpendicular, slide it up till it goes on top of the pivot. Then we can draw it. There's our moment arm, there's our perpendicular. Now we're going to use some geometry to sort out what that R perpendicular is. So this angle is 60 degrees. That's on the inside of this Z, so that one is also 60 degrees. If this is L over 2, then this is L over 2. And if we look at our right triangle, this is the hypotenuse. This side is adjacent to a 60-degree angle, so we can use cosine to find it. R perpendicular equals L over 2 times cosine 60 degrees. So 4 meters divided by 2 times cosine 60 degrees. Let's do that through the calculator. So 4 over 2 is going to be 2 meters times cosine 60 gives us R perpendicular of 1 meter. And there's our moment arm for that guy. Next, we'll draw our forces perpendicular and parallel. Let's go onto a fresh sheet of paper there. So for those forces, we want a component of force that is parallel and a component of force that is perpendicular. For the part that's perpendicular, we know we want to be perpendicular to the post, and we want to go only as far as this guy. We don't want it to be any longer than that one. This one probably looks a lot like drawing those components of the weight vector. So there's our F perpendicular, there's our force. Just to be complete, let's draw in the force parallel. That's the part that's parallel to this one, only goes down that far. So there's F parallel. If we want to find F parallel, we've got to do some trig, we've got to look at some geometry. This angle is 60 degrees right here. If we came down all the way, this would be a 90. These three are in a triangle. This one would have to add up to be 30 degrees. And then this one is perpendicular, that one's parallel. Those two would have to be 90, so that one must be 60 degrees. So the magnitude of our force, 45 newtons, is the hypotenuse. F perpendicular is adjacent to 60 degrees, so we can use cosine. Let's grab the calculator and we'll find out what that is. 45 times cosine 60, 22.5 newtons. This time that's the perpendicular component of the force. Okay, we've got one more to go and we'll do that next.